Jaya. Jaya.
Ya.
Aku tekan go live, dia tak go live. Pasal dah overview ke macam ni? Aku tekan live, dia tak nak pergi live.
Okey, tak apa. Buat baru.
Macam mana?
Buat baru. Schedule baru.
Okey, dah on.
Right.
And a very good afternoon to all viewers. It is a great pleasure to welcome all viewers to the 11th series of Research and Innovation webinar, School of Electrical Engineering. My name is Sherry, the moderator for today's session. This program is brought to you live from School of Electrical Engineering, Faculty of Engineering, University Technology Malaysia's Facebook. Without further ado, I would like to invite Professor Dr. Muhammad Kamal Ibrahim, the Associate Chair of Research and Academic Staff, to give a short opening, as well as introduce our guest speaker, Dr. Rozeha Bt, the Head of Telecommunication Software and Systems Research. Over to you, Prof.
Thank you very much, Puan Sherry Huzaimah, for hosting this event. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to all viewers. Thank you once again to all viewers that follow this webinar to our FB Live School of Electrical Engineering. My name is Professor Muhammad Kamal Ibrahim. I'm the Associate Chair of Research and Academic Staff, School of Electrical Engineering, University Technology Malaysia. Our topics today entitled Making Sense of Internet of Things environment that will be given Head of Telecommunication Software and System Research Group, Dr. Rozeha Bt. Rashid. Before she gave his presentation, I would like to introduce our speaker today. Please share, like, and comment our FB Live School of Electrical Engineering. Dr. Rozeha Bt. Rashid received a Bachelor of Science degree Electrical Engineering from the University of Michigan and Ann Arbor, United States of America, and her Master of Electrical Engineering and PhD degree in Telecommunication Engineering from the University of Technology Malaysia. She is a senior lecturer in the Communication Engineering Program, School of Electrical Engineering, University of Technology Malaysia, and is currently the head of Telecommunication Software and System Research Group. She is an IEEE member and has more than 140 publications, mostly in the area of telecommunication engineering. Her current research interests include wireless communication, sensor network, connected radio, as well as Internet of Things. The webinar is divided into two parts. The first part gives the introductions to the IoT and the components that institute to the IoT environments. The second part of the webinar is the introduction to Telecommunication Software and System Research Group, the IoT solutions, as well as the current research activities. Now, I would like to invite Dr. Rozeha Bt. Rashid to give a webinar on making sense of Internet of Things environment. Over to you, Dr. Rozeha.
Thank you, Prof. Kamal and Puan Sharifah Huzaimah. So I would like to say my greetings. Assalamualaikum and good afternoon. I am Dr. Rozeha. So the title of my presentation today is Making Sense of IoT Environment. So as mentioned by Prof. Kamal, my presentation will be divided into two parts. One is part one consists of understanding IoT, making sense of the things and connectivity, making sense of cloud platform, and making sense of data. And the part two is about my research group, TeSS, TeSS IoT stories, and the active research projects. So for part one, actually, I will start with understanding IoT. So when Kevin Ashton coined the terms IoT 21 years ago, the dry definitions of sensors and actuators embedded in physical objects that are linked to wired and wireless networks seems not quite capture the potential of IoT. So a smart home, a smart cities, industry 4.0, autonomous vehicles, as well as healthcare and the many other aspects of all benefit from what we means when we say IoT. So the increase in number of connected devices per person over the years is quite dramatic. I would say from only negligible number of in 2003 to about 7 devices per person in 2020. So the turning point here is around 2007 and 2008, where the number of connected devices exceed world population. Sorry, I don't know where to. So the 5 stages of IoT, as can be seen from the slide, are the device connectivity and data forwarding. So this is the simplest one. So you can start with the first stage, which is very simple, to the most sophisticated one, as you can see at level 5, enhancing onboard intelligence. So the first stage, device connectivity and data forwarding, is for the purpose of second stage, real-time monitoring. So from the real-time monitoring, we can have data analytics in the third stage, which will give you insights to the fourth stage, where IoT system can be automated, and then from the automation, we'll go to the fifth stage, where you will have enhanced onboard intelligence. Okay, let me give an example. You can have, if you have a car, okay, if you want to somehow deploy IoT on a car, the simplest thing is to install a GPS sensor. Okay, so when you include the GPS sensor, you can have real-time monitoring of your car, whether your car is moving or not. Now, if you see right now you are here, but your car is moving. So basically, you know that you are not driving it, so it must be stolen. So in the case of this, you want to move to the third stage of the IoT, the maturity stage of IoT, where you have some control of your car based on the data analytics that you capture from your GPS. You can actually set the geofencing feature on the GPS. So if your car moves outside a certain area, it will be immobilized. Okay. So once it is immobilized, then you can have actually do other automations, such as for alerts for car maintenance, and then security lock remotely, and so on. Okay, if you reach your car actually has the sort of IoT intelligence in the fifth stage, by that time you will have autonomous car, such as Google Car, Tesla, and Uber, meaning that you don't have to drive the car will drive itself. Okay. So in short, it seems to make sense that an IoT environment can be achieved using this equation: sense plus infer plus act. So the sense can be achieved by installing physical objects such as sensors, and with the help of internet connectivity via communication such as Wi-Fi, LoRa, 5G, then you can actually to somehow put your sense data into a facility, normally a cloud platform. So on the cloud platform, you can perform, you can store the data and perform process as well as some data analytics and rules engine mechanism. Okay, so from this analytics, you can actually do some action where you can actually, once you capture the data, you can actually do, for example, some sending alert, or you can also populate the dashboard accordingly, and then you can also control some operation remotely and so on. Okay, so the word IoT is that, long live IoT. So basically from what we have learned so far, from the understanding of IoT equations, the IoT terms coined by Kevin Ashton 21 years ago is already there. So the term of IoT as sensors and actuators embedded in physical objects that are linked through wired and wireless cannot be used anymore. It cannot quite cut it. So it has to be coupled with the ability to make sense of the data captured and take a meaningful actions to make it alive, to make IoT alive. Okay. So this is basically to make sense of the things and connectivity. This is me trying to make sense of IoT and connectivity. Very confused. Basically, the cyber physical objects is about sensorizing objects, people, supply chains, and environments to digitize the physical world. Okay, so from here, actually, you can have from trying to make sense of the things and connectivity. So you can have actually active and passive sensors combined with processor to lend it some intelligence, as well as integrate it with some sort of communication connectivity to get access to the internet. So the sensors can be active or passive sensors, and then you can have a processor. There are quite actually a number of processors available nowadays. Besides Raspberry Pi, you have Arduino and else. And then with the technology connectivity for the internet, you can achieve Wi-Fi, LoRa, narrowband IoT. Basically, this is to capture the physical world data and brings it to digital domain for the purpose of making sense of the data. Okay, so there is a need for convergence of the things in IoT and the traditional sensor network. So last time actually we have the traditional networks such as OPC, okay, onboard processing unit, and you have SCADA. Also you have historian, and then you have certified hardware. Okay, so IoT in general is a system where the things directly send the data to the internet. Okay, so with you can actually transform the traditional system of OPC, SCADA, historian, and certified IoT by integrating with the IoT platform, which acts as software as a service on premise to somehow convert this traditional network into IoT. So sort of IoTize your traditional network into IoT network. So sensor network in general has no direction, has no connection to the internet, and sensor network can be classified as simple sensor and become an IoT device when connected to internet. Okay, so the standards. So those communication technologies actually have different standards, have its own standard. So if you can see here, the situation, for example, there are 14 in the cartoon there, then there are 14 competing standards. So this is ridiculous, right? To make decision which standards you want to choose. So by right, we should have a universal standard that covers everyone's use case. So soon, instead of having one, we have 15 standards. So basically, the connectivity of the things provides network infrastructures and communication capabilities. So this connectivity is needed to collect, transport and exchange data over the internet and to be remotely monitored and controlled. So it can be categorized into two major categories, which is transport protocols and data protocols. So I would say I will put the connectivity equation as transport plus data. So if you see lots of equations here, because we are engineers, so I like to somehow put my making sense of the IoT into equation that can be understood, easily understood. Okay, so for the connectivity, there are several communication technologies available. So we have actually for the transport protocol provided by these technologies, the Zigbee, Wi-Fi, low energy Bluetooth, 2G, 3G, 4G, narrowband IoT, and etc. While the data protocol actually can be achieved using HTTP, HTTPS, MQTT, constrained application protocol, and etc. So how do you choose actually? So let me remind again that this chart is just to show the theoretical range, the maximum theoretical range with regards to the data rate for each technology. So you can see that for the ones that occupy the low data rate, the Wi-Fi, you have the Zigbee, low energy Bluetooth, only can cover a short distance. So when you move further up, you can have like a longer distance, but at the expense of maybe a lower data rate. So then you can see that you have low power wide area network technologies as LoRa, narrowband IoT, occupying a very long distance but at a much lower data rate as well. So the ones that actually with high data rate and also long range is occupied by satellite technologies. Okay, so over the years, there is actually a convergence of IT and operational technologies, industrial automation. So you can see that in the beginning, 1970s up to, I would say in the 1990s, information technologies and industrial automations are two different entities. They took two different individual paths. Okay, but as from 2000s, in the year 2000, it began to converge. Because right now you have integrated architecture in one chip. All right. So by 2010, there is already a five-layer architecture status quo in the industry, where you have the input-output, then you have the programmable logic controller, then you have SCADA, and you have MES and ERP. But now, as of 2020, these layers, the line of the layers becomes a bit blurred. So it no more follows the five-layer architecture as of 2010. So this is actually made possible because the five layers stack right now has been the lower layer has been converged. Some of the lower has been converged. So in this case, like the input-output and the PLC and DCS can be combined to become what you can call edge-to-cloud architecture. So this functionalities right now has been pushed to the cloud, right? So and then the edge-to-cloud architecture can be enabled using this connectivity technologies, Sigfox, LoRaWAN, and narrowband IoT. And then the novelty actually of the future of connectivity is that it allows the teams to achieve edge-to-cloud connectivity because due to the advancement in computing hardware and software. So you can actually, how do you decide which technology connectivity technology to choose depends on some, I would say, factors. So those factors can include scalability, range, coverage, deployment, cost efficiency, battery life, quality of service, payload length, or latency performance. For example, if you want to have a technology that provides high quality of service and high scalability, you might want to choose from the spider web. We can see that you might want to choose the narrowband IoT, while if you want to somehow choose a connectivity technology that is low in cost, easy to deploy, and then have a good coverage, but somehow then do not have a good, it has a high latency. So you might want to choose LoRaWAN or Sigfox. Basically, you can see that LoRaWAN technology falls in between narrowband IoT and Sigfox. Okay, so to make sense of IoT cloud platform, there are so many cloud platforms out there. Okay, so what it is actually, cloud platform is a platform that you can create and manage applications, to run analytics, and to store and secure your data. This is the definitions of IoT cloud platform from McKinsey. So if you can see the comment there, what do you think that cloud looks like? So basically, take a picture and post it to Google. And then the Google just gives you an answer. The best guess for this image is cloud. So basically, keep trying Google. So this shows that how confusing, all right, or how challenging, how it is challenging actually to choose the correct cloud platform for your applications or use cases. So some criteria that you might want to consider in choosing the cloud platform include hardware integration. So whether the cloud platform can support various types of hardware, device management, device credentials and status, data collection, whether it is large scale with production ready databases, the rules engine, whether it can control device behavior, integrations with other applications such as REST, WebSocket, data analytics, business tools, and then whether it can actually execute commands, as well as it offers easy connectivity to IoT connectivity technologies such as LoRa, Sigfox, and etc. So right now, the cloud platform services is actually can be roughly defined as the place where you can ingest, analyze, and interpret the data at scale through cloud technologies that can generate some insights. So this is a platform as a service. So the market for IoT platform actually is growing. So as you can see, from 2018 and 2023, there is a 39% increase to 22.3 billion USD. Okay, so the market leader for cloud platform now is held by Microsoft. And then the 5 types of IoT platforms right now provides application enablement, cloud, device management, connectivity, and some analytics. And the biggest segment is for manufacturing, and ASEA is the biggest region to somehow for the cloud platform users. And there are 20 leading vendors as shown. I don't know all of them. Okay, but the most, I think, popular ones, you can see Amazon Web Services. You have also there IBM, Watson's, You have from Siemens, you have Microsoft, Azure. So then in order to choose the best cloud platform for your organization, you might want to compare according to this criteria, where you have IoT platform building blocks, tech stack, business and pricing models, market segmentations, industrial vehicles, partner ecosystem, customers and marketing perspective, as well as case studies. Okay, now we reach for the topic of making sense of data. Right. As mentioned right now, IoT, the conventional definitions of IoT as coined by Kevin Ashton last time does not cut it anymore. So it must be coupled with some insights of the data captured. So how to make sense of the data? So as you can see from the comic, okay, this is your machine learning system. Yep, you pour the data into this big pile of linear algebra, then collect the answers on the other side. So what if the answers are wrong? So just stir the pile until they start looking right. So basically what we want to make sense, why we want to make sense of the data is that managing and making sense of such data is essential if IoT solutions are to deliver value. So data analytics can be categorized into a pyramid scale. All right. So the lower layer of the pyramid is about descriptive analytics. Okay, so this will give the information, some insights from the information captured. All right. Then you have the diagnostics analytics. So why it happened. So some knowledge. And the next state, the next level on the pyramid is the predictive analytics. So it becoming smarter. So it has some prediction what is likely to happen, some understanding of the events. And then you have also prescriptive analytics, what actions to take. As mentioned just now, my idea of IoT environment consists of sense, infer, and act. All right. So what to do with the data actually is to sort out the data. Okay. And then you need to transform, aggregate, integrate, and of course, we have to include some data security to ensure its integrity, privacy, and of course, some storage for data itself. And then the analytics, you can carry out distributed, meaning that it can somehow be passed through to the devices itself, and it can be carried out real time, and then it can be carried out at the edge, okay, at the gateway. So the descriptive analytics, the lowest layer of the data analytics, if your system has some sort of dashboard that shows some statistical analysis, some pie chart, some histogram chart. So basically your system has the level 1 of data analytics. So if your system can do data mining, then your system does have some sort of diagnostic analytics. So to be able to have some predictive analytics, you must use a more sophisticated methods such as machine learning, regression, classification, and regression trees. And for prescriptive analytics, these methods or algorithms must be performed. So basically, it can consist of a combination of descriptive and predictive methods, as well as some rules and optimization that leads to optimized decision making. So in short, it must have some sort of artificial intelligence in the analytics. So that is so basically I finished the part 1 of my presentation today. So for part 2 of my presentation, I would like to introduce my research group, Telecommunication Software and System. So what we have done or what we have as our IoT solution, and the active research projects that we have currently. Okay, so this is Telecommunication Software and System Research Group. We have currently 8 members. Okay, so we have Dr. Adib, we have Dr. Omar, we have Dr. Shahidan, we have Associate Professor Dr. Muhammad Nasir, Dr. Yo, as well as Mr. Samra and Mrs. Siti Zaliha. So all of them actually are talents with their own specialized area. Okay, so TeSS actually managed to somehow deliver or develop some IoT commercialized solutions. Okay, so here I want to share some IoT stories from TeSS. So we have actually developed IoT access door and alarm system. So this is used currently at UTM, such as School of Electrical Engineering, School of Energy, as well as at Siam. Alright, so from there we can see that the sensors used is NFC. We can actually use 2 technologies, NFC or RFID. But in the case of ST, we use NFC card to get access to the labs. And we have magnetic lock as sensors, as well as alarm and wireless gap sensor. So this will go to our controller and gateway, and then sent to the server to be able to be displayed on the enterprise application, such as you can have web browser or you can actually see on your smartphone, right? So in terms of actually access, we have delivered access not just limited to NFC and RFID cards. We can also grant access using face recognition and also fingerprint. So this is actually the dashboard of our access door and alarm system. And we also have developed what is called GuardExpert Pro, IoT-based security guard management. So what this system is all about, basically the conventional guard Turing system, guard patrol system, use a battle light device to do patrolling and insert the battle light device into the keyhole for checkpoints, okay, to lock on the checkpoints. So since we are now in the IR 4.0, that one actually is very outdated, since then the guard has to go back to the guardhouse and upload the checkpoint logs manually. All right, so we have developed an app that can do the checkpoint scan, as well as we have integrated with other functions as well, such as panic button and the location tracking of the guards. And then all the information is uploaded to a server to be displayed via a dashboard using web browser or on the smartphone. So our system actually have been commercialized and have been installed actually at organizations such as Dynamic Guard Force in Berhad, PIDM, as well as at UMW. Okay, so we also in the works for the same thing, actually location tracking, but instead for this one actually is for outdoor. So we can actually track the guard's location, do the location tracking using GPS. But everybody knows that GPS is cannot be used for indoor tracking. So we have currently 2 grants that we somehow utilize to develop indoor tracking. One is for the smart facility management, where we integrate actually a smart access terminal where the terminal can be used for access as well as for checkpoints using the same using different the card, or actually the devices that is specific for the purpose of patrolling indoor. Okay, so I like to mention again for our GuardExpert Pro here, the location, the checkpoint scan actually can be enabled through 3 different types of mechanism. It can be enabled, the checkpoint can be locked using NFC technology or RFID as well as geofencing. So if like this is actually according to customer requirement. Okay, so for this indoor location tracking, as mentioned, for this one actually it is enabled through smart access terminal. While there is another, and on top of that, this is, we have also utilized low energy Bluetooth beacons. Okay, so this is more for room scenario where you have actually, and you can install actually several beacons inside the room and trace the movement of the person carrying the device, the handheld device as shown there. So the handheld scans the beacons and calculate the estimated position, and then it will be displayed on the dashboard using MQTT protocol. Okay, so we have also UTM Smart Barrier. Right now there is a prototype being implemented at the Senai Gate. So this is actually IoT based vehicle access management. So I think everybody knows already. By right, we need to have RFID, UTM RFID car sticker for all of campus citizens, regardless whether they are staff or students. So you can see from the first picture, the sample of UTM RFID car sticker. So once we registered that, basically the entry exits of the car UTM car that carries official car UTM car sticker actually can be automated because you can see that we will have the RFID reader installed at the barrier. So once the RFID reader detects the authorized car sticker, then the barrier will lift automatically, right? So there is also a camera that in future will have plate recognition capabilities. So asset tracking solutions, this is for MMHE. We have spool tracking solution where due to their requirement actually, because they have a very big yard that place where all the spools are actually the pipes needed for oil rig. Okay, so there are many types and sizes. So they sometimes their loss for the spool actually can reach up to millions. So we come up with a solution to help them be more organized and easier for them to locate the spool by providing them with RFID tag. So the RFID tag, the red box there is the RFID tag, which consists of 2 types of RFID. One is the passive RFID and another one is active RFID. So the passive RFID is to somehow using the mobile device. Once we press the RFID for the spool that we are searching for, then we'll get the zone where it can be, it might be located. So, but there are many, because there are so many spools there. So we might want to, we can activate the active RFID to somehow get a specific, more accurate search. Okay, because for active RFID, it will start beeping when you come closer to the target location. Okay, for the warehouse IoT warehouse management system, we provide this system for Shimano. So the advantages is actually it can move the goods, the movement of goods can be tracked in real time. there is one advantage of IoT actually. So shelf space can also be managed more effectively. Inventory control also is improved. So the amount of human involvement in the supply chain management is reduced considerably. What we do actually, we just install RFID reader on the forklift, and then the RFID tag on the pallet as shown, as well as on the rack. So basically, the driver of the forklift does not have to come down from the forklift. It's just go to pick up the pallet which carries some container and read from the RFID tag the informations of the container, communicate with the database to somehow get the locations where the container must be placed. So once it reaches the rack where the container must be placed, there is another RFID tag there. So if it matches with the RFID tag on the pallet, then it means it's the right location for the container to be placed. Okay. So we also have delivered IoT-based queue management system for alphabetic printing. So it is actually a web-based system that is designed to help service provider to manage customer in a more efficient way. So another of I would say our IoT solution that we have delivered is waste recycling and collective systems application, where we provide mobile apps to effectively manage the waste and for campus sustainability, as well as the dashboard to monitor the data that is captured using the mobile apps. Okay, so we also have deliver also IoT-based photovoltaic energy monitoring system, PVEMS. We have conducted several IoT training for the industry, such as BMW, and also a technical update stock with Datasonic and also Telecommunication. Okay, now for the active research projects in TeSS. Okay, so we have actually running active research projects called AMER CPU that is that belongs to Associate Professor Dr. Muhammad Nasir. So this is in future if the vision is actually to have the CPU in future to replace Raspberry Pi and the likes. Okay, so and this research is using the RGS grant. I have also active projects on LoRaWAN. Basically, this is to investigate the relationship of LoRa upchirp and downchirp signals with simultaneous uplink and downlink transmission. Another research that we have for 5G application is the service-oriented middleware for home area network. So the advantages of this research should be a smart management and to minimize the wireless sensor network resources. This is to ensure minimum network latency by limiting the data packets transmitted by sensor nodes. Okay, so this research targets to for smart home application without adding new sensor nodes by reusing services provided by the existing nodes. Okay, so we have also active research on wireless signal characterization for dynamic asset tracking in industrial facilities. This research actually is supported by our collaborative research grant in collaboration with UNIMAS, USIM, and UMT. It is to conduct, one part of the research is to conduct the wireless reserve signal strength characterization measurement inside a warehouse-like environment at several sub-6 GHz operating frequency. And under UTM encouragement grant with Madam Siti Zaleha as the project leader, we have IoT-based noise monitoring system in residential area. So this is supposed to support smart cities environment. Again, this is under UTM encouragement grant. We under Mr. Samura. We have lossless image compression using multiple half-moon table. So in our team, Encik Samura is the security guy. So under Dr. Yo, we have research on microwave material characterization, microwave passive device design, microwave high power system, as well as microwave electronic design automation. And we have another research for IoT-based topology control, where we try to actually develop an optimizer then that can interactively minimize the transmit power for the purpose of maximizing connectivity efficiency. Under Dr. Shahidan, we have the quality of service aware-based software-defined network using reinforcement learning. So lately, actually, we have a few research that include machine learning and reinforcement, and this is one of it. So this is to investigate the cause of network latency and to optimize network performance and QoS using reinforcement learning. Okay, so this is the letters of our venture into upgrading our security solution that we have delivered to company that we have commercialized before. We try to incorporate drone technology in our security solutions. We have secured some grants from UTMPR as well from Iconic. The latest is Iconic grant to develop this system. So what we have in mind actually is instead of just terrestrial patrolling, our solutions, IoT security solutions also will include aerial surveillance as well as aerial patrolling. Not just the drone actually won't just be used for surveillance and patrolling, but as well as first emergency responder. As mentioned before in the slides, for our guard patrolling system, we have a panic button to assist the guard in case of being abused. So once the guard press the panic button, not just basically the guard house will receive the call for the panic alert, but this will also mobilize the drone to get a first eye view of the incident. Okay, so the drone will be mobilized first. So the drone in this case will be the first emergency responder to any incidents. Okay, so we have also machine learning assisted interference mitigation for wireless sensor network for IoT application. So this is to investigate and develop lightweight feature extraction method and machine learning model for radio frequency interference mitigation in wireless sensor network. And we have also research projects on energy efficiency in cognitive mindnet IoT. So these are the many beneficial. Some of the beneficial users is that it can actually improve the lifetime of the network, because in this project, the research is trying to somehow develop to an energy efficient route discovery mechanism for this cognitive mindnet IoT application. Okay, so that's it from for the presentations today. So back to you, Prof. Kamal.
Okay, thank you very much to Dr. Rozeha to give a webinar on making sense of Internet of Things. So again, I would like to take this opportunity to thank Dr. Rozeha for sharing a very informative session. Now I would like to open for any Q&A session to all viewers. You can post your question to the Facebook Live here. Okay, before that, maybe I have one question here, Dr. Rozeha. In your opinion, what is the state of IoT development in Malaysia?
Actually, currently, there are many IoT or IoT-related initiatives rolled out by the Malaysian government in the past few years, such as the National Internet of Things Strategic Roadmap, launched in 2015, as well as Malaysia National Policy on Industrial 4.0 in 2018. And currently, just last month, we have National Technology Innovation Sandbox being launched. So in my opinion, these are positive developments for IoT technology growth in Malaysia.
Okay, how do you rate the industry's readiness in Malaysia to adopt the IoT technology?
From our interactions with industries, basically the industries in Malaysia has the motivation to embrace the IT technology, and they understand the need for it. Some are ready, some are preparing for it, some already have IoT applications up and running to a varying degree, and some don't bother about it at all. So basically, why? The reason, sometimes the challenges include funding and factors such as perception towards the technology, such as optimism or skepticism.
Okay, last question. How do you choose an IoT platform that is best suited for your IoT-based application?
I think I presented this in one of the slides. I mentioned it in one of the slides. The decision can be based on criteria such as hardware integrations, data analytics, device management, and etc.
Okay, all right. With that, thank you very much, Dr. Zha. Now I would like to pass over to Puan Sherry for closing and introduce our next webinar series on research innovation, School of Electrical Engineering, Unity Technology Malaysia. Over to you, Puan Sherry. Tak dengar.
Wabarakatuh.